This video is for section 4-7, using factoring to solve equations. Back in section 2-6, we saw the zero product theorem. If you multiply two factors together and the answer is 0, then you know that either of the factors is 0. We can use that theorem to solve equations that have polynomials, if we can factor them. So here is another application of factoring, a reason why you need to know how to factor algebra expressions. The first step in solving this problem is to get it to equal 0 so that it fits our theorem. And we can do that by subtracting y from both sides. That creates y cubed, subtract 4y equals 0. Then factor the left side. There's a greatest common factor of y, and that leaves y squared minus 4. And that's equal to 0. Continue the factoring. The y squared minus 4 is a difference of squares and factors with the double parentheses. Y times y is y squared, and positive 2 times negative 2 is the negative 4. This expression has three factors, and it's equal to 0. That fits the theorem above if you imagine that there was a third factor, perhaps a times b times c equals 0. You would know that either the a or the b or the c was 0. The point is, if these things are multiplied together and the answer is 0, that at least one of them must be 0. Maybe it's the y. So you write y equals 0. Or maybe it's the y plus 2. So write y plus 2 equals 0. Or maybe it's the y minus 2 that is equal to 0. Solve each of these equations. The first equation is already solved for y. The second equation ends up being y equals negative 2, and the last one ends up being y equals positive 2. What we figured out are three possible answers for y: 0, negative 2, or positive 2. If you used any of those numbers in the original equation, that would make the equation true. If this solution process leads to identical factors, then there are double roots. But you only write that once when listing the solution side. Let's try an example of that. Solve this equation. It already has the equals to 0. We need to factor the left side. First, factor the GCF of 5, leaving t squared minus 6t plus 9. And that's equal to 0. Then factor the trinomial. That is a perfect square trinomial. It factors as t minus 3 squared equals to 0. This fits the zero product property. Things multiply together where the answer is 0, so at least one of the factors must be 0. The first factor is 5, but 5 can't be 0. We can ignore that. The next factor is a t minus 3. That could be equal to 0. And the next one is another t minus 3, but there's no need to write the same thing twice. So solving for t, we get t equals 3, and that's the solution to this equation. Let's summarize what we did in those two examples. First step, transform so there's a 0 on the right side. Second step, factor the polynomial on the left side. And the third step, use the zero product theorem to find the root of each factor. Let's try one more example, this time a real-life situation. The altitude h of an object t seconds after being thrown vertically upward with a starting speed of r feet per second from an altitude of k feet is given by this formula. If you've already taken physics class, you'll recognize this formula for moving objects. Use this fact to determine when a ball tossed upward with a speed of 48 feet per second from a terrace 300 feet above the ground will be 236 feet above the ground. That was a really long paragraph. This picture helps explain what's going on. Here is the ground. Here is a terrace, which is 300 feet above the ground. and there's a person standing on the end of that terrace with a ball in his hand. He tosses the ball upwards. Because of gravity, it will slow down and at some point start to come downward. The question is, how much time does it take for the ball to reach a height of 236 feet above the ground? This physics formula gives us a way to get the answer. Let's make substitutions. The letter h is the height of the object. In our case, we want to know when the height of the ball is 236 feet above the ground. Substitute 236 for h. The letter r is the starting speed. We're told that the ball is thrown with a speed of 48 feet per second. Fill in 48 for r. The letter t is the time that the ball's in the air. That's what we're asked to figure out. So leave it as the unknown variable t. Then minus 16t squared plus k. In the paragraph, we're told that k is the starting altitude of the ball. That was 300. Here is an equation with the variable t. We can solve this equation with the process we're practicing today. Let's get a polynomial on the left side and 0 on the right side. So first step, add the 16t squared. Now we have 16t squared plus 236 equals 48t plus 300. Next step, subtract the 48t. We have 16t squared minus 48t plus 236 equals 300. Next step, subtract 300. 16t squared minus 48t minus 64 equals 0. We've accomplished step 1. We have a polynomial on the left side and 0 on the right side. Step 2, let's factor. All terms divide by 16, so factor a 16 at the beginning, leaving t squared minus 3t minus 4, and that's equal to 0. The trinomial is factorable. We get 16 times t minus 4 times t plus 1 equals 0. I used negative 4 and positive 1 because they multiply together to make negative 4 and add together to make negative 3. Now let's do step 3 of our process and find the solution of each factor. 16 cannot equal 0. We can ignore that. The t minus 4 might equal 0, or the t plus 1 might equal 0. Solve each of these. T equals 4 seconds, or t equals negative 1 seconds. Because this is a word problem, we need to check these results into the context of the problem. Is it possible to throw a ball in the air and after a little bit of time it starts to come downwards, and 4 seconds after you throw it, it's 236 feet above the ground? Yeah, that seems possible. Let's check the second answer in the context of the problem. Is it possible to throw the ball in the air and have a negative amount of time go by? That doesn't make any sense. So we cross that answer out. It doesn't fit the context of this problem. Our answer is 4 seconds. Let's summarize the lesson. We learned a technique to solve equations that have polynomials in them. This expands the types of equations that you'll be able to solve and will allow you to solve equations in contexts of science, engineering, finance, or other situations.